Okay, first question. Describe how a solution of sugar in water is used to produce the mixture of ethanol and water. 2 marks. Okay, so we've got a sugar and water solution and somehow it's turned into an ethanol and water solution. Well, this is done firstly by using a yeast catalyst. Okay? And the second way this is done, well, mention the temperature, okay, say it's about 30 to 40 degrees C. This is fermentation, so get that down on the page. Okay, and an important part of fermentation is that you restrict the oxygen. Okay, this fermentation works because the yeast doesn't have access to oxygen. So it's a 2-mark question, so exam technique again. Get everything down you can think of that's relevant. Okay, yes, there's only 2 marks available, but you don't know which one of these the examiners are looking for to get you the mark, so get them all down. Okay, you need a yeast catalyst, or just say add yeast, give a temperature, fermentation is about 30 to 40 degrees C, get the word fermentation down and say no oxygen. Good, okay. Describe how ethanol is produced from ethene. Okay, well, I'm going to draw it out. So here is ethene. Ethene is a carbon double bonded to another carbon with 2 hydrogens on each carbon. Okay, and what does it want? Right, hydration. Okay, so it's being reacted with a water molecule. Yeah, I'll draw it out. H2O. And it's going to make ethanol. So we end up with this. That's ethanol. Okay, C2H123450H. So there's 6 H's in total, but you'd write it as C2H5OH. Okay, what was the question again? Describe how ethanol, okay, he wants to know how it's produced. Well, to get the marks in the exam, they want you to mention that you react ethene with steam. Okay, so get the word steam down. Okay, that gets you one of the marks. And yeah, the other mark, yeah, it's a 2-mark question. It needs to be done in the presence of a catalyst. Okay? Again, exam technique, get everything down you can think of that's relevant. Mention the catalyst. It's phosphoric acid. Which is H3PO4. Okay, write all this down. Anything else that's relevant? No, that's it. Okay, that will definitely get you all the marks, the 2 marks. By steam, what they mean is this is a vapor. The water is in gas form. It's above 100 degrees C. It's above the boiling point of water. It's actually done at about 300 degrees C, okay? You don't need to say that to get the marks, but I'll write it there anyway because it's relevant for a later question. So I'll put that in brackets because you don't really need to know that. Just mention steam. It's hot. Okay, yeah, let's move on. Explain one advantage and one disadvantage of using crude oil to make ethanol instead of plants. Okay, well that's the plant way of making ethanol. That's the crude oil way of making ethanol, because this ethene comes from cracking, which in turn comes from fractional distillation, which is only possible because we pull a bunch of crude oil out of the ground. So I'll just write that down. We've got crude oil, which is fractionally distilled and then cracked, and that produces ethene. Okay, that is ethene. Right, so that's the plant method, because we get sugar from plants. And that's the crude oil method of making ethanol. Okay. Right, one disadvantage and one advantage of using crude oil instead of plants. Okay, so it stresses in the question you have to pick one advantage and one disadvantage. But it's a 4 mark question. So that means you're going to get 1 mark for saying what the advantage is, and then the 2nd mark for explaining it. Then the 3rd mark for saying what the disadvantage is, and the 4th mark for explaining it. So you've got to read the question carefully and always be, boring I know, but you've got to be aware of exam technique and do what they tell you to do. So you've got to separate the reason and the explanation. That's my point. Anyway, okay, first possible reason you could use. You could say that crude oil is a reliable source of ethene. Okay, that's the reason, 1 mark. The explanation. For the foreseeable future, we have a constant supply. Not in the long term, but in the immediate future, we have a constant supply of crude oil and therefore ethene. So the supply is reliable. But in this case, plants, the supply of sugar is affected by the seasons and the weather. Is it raining? Is it sunny? These sort of factors. So that's the explanation. Okay. You only have to give 1 advantage, okay, but I'm going to give you 3 here and pick your favorite. Okay, reason. Another reason is that this method produces pure ethanol, okay? It's the only thing on the right hand side of this equation. But this method, the ethanol is still mixed in with the solution in the reaction mixture, so it has to be separated out. So the reason is this crude oil method produces pure ethanol. The explanation is that this is the only product on the right hand side of the equation, whereas with the plant method it has to be separated from the water solution. Okay, another advantage of crude oil method is that it's quicker. And the explanation is that the reaction vessel that this steam hydration is performed in is always running. It's a continuous process, okay? Whereas the yeast fermentation method is a batch process. That means it has to be stopped and started. You set off 1 batch, when it's finished, you stop it, and then you can isolate the ethanol. Whereas this is continuous, it's always running, and the ethanol is effectively just being continuously produced. Okay. Note the correct use of the word continuously there. Continuously means without pause. So you could say, this is more of an English lesson than chemistry, but the crude oil method, the ethanol is being continuously produced. In the plant method, the ethanol is being continually produced. That means there are breaks, but it keeps going. Continuously and continually mean different things. Okay, let's move on. Right. Okay, so that's 3 possible advantages and their explanations you could give. Remember, you've only got to give one. Answer the question. Now you've got to give a disadvantage. I'm going to list 2 here. Pick your favourite. But like I'm saying, exam technique, do what they tell you. Don't give 2 disadvantages. You have to give 1 advantage and 1 disadvantage. Okay. Right. The disadvantage of this method is that crude oil is a finite resource. This ethene, as we've written here, ultimately comes from crude oil, and that's a fossil fuel. It's a finite resource. Whereas plants are a renewable resource. They grow back. Okay. And the final disadvantage of the crude oil method, it's more harmful to the environment. And the explanation is that crude oil, this process uses more energy than this process. Moreover, this process burns more fossil fuels and releases more CO2. Okay? And the explanation is that CO2 is a greenhouse gas and can lead to global warming, whereas the plant process releases less CO2. Okay. Now, you might be saying, hang on a minute, I can't see CO2 as a product of this reaction, but you're telling me that this method produces more CO2. But also, I know, let's draw the equation for this. So it's sugar, that's C6H12O6, okay, glucose, makes ethanol, which is C2H5OH, and CO2. Okay, to balance this, there's a 2 there and a 2 there. Okay, so that's the actual chemical reaction that's going on in the plant method. You take your glucose, and with a yeast catalyst it makes ethanol, but it also releases CO2. And I just said that this method releases more CO2. So how is that possible when the actual chemical reaction that's going on here releases CO2? Okay, so that's the sugar there, that's the ethanol there, and that's the CO2 there. Okay, right. The reason is, yes, this process does release a bit of CO2. It does. But the CO2 from this whole process doesn't come from this reaction. It's released because I told you we'd get back to this temperature. It's done at a very high temperature, 300 degrees C, and you have to burn fossil fuels to heat this reaction to that temperature, and that's where the CO2 release comes from. Okay, it's very important you realise that. Cracking, the process of cracking itself doesn't actually release CO2. Okay, cracking, you're just vaporising the products of fractional distillation, sending them over a catalyst. But you're not actually burning anything. You're not reacting it with oxygen, so it doesn't produce CO2. Nor does fractional distillation. You're just heating the crude oil up in fractional distillation and then recondensing it. You're not actually burning. You're not reacting anything with oxygen. So the CO2 comes from that temperature. You're burning stuff in order to get that 300 degrees C. Okay, moving on. Right, the last bit. Ethanol has a boiling point of 78 degrees C. Water has a boiling point of 100 degrees C. Describe how distillation is used to separate a mixture of ethanol and water. 3 marks. Okay, so I'll do this in a different colour. Right, well, how does distillation work? So what you do you take your, this is an oversimplified diagram, but it's the essence of how it works, okay? You take your mixture of ethanol and water, okay? They're both liquids at room temperature, so, and they're both miscible with each other. That means they're soluble with each other. They don't separate out into two layers like oil and water would. Oil is not miscible with water. Ethanol with water is. I mean, just look at a bottle of vodka, for example. That's roughly 50-50 ethanol water. And you can't see two layers in a bottle of vodka. Okay. So, what you do is heat the solution of ethanol and water, okay? And according to the mark scheme, that gets you 1 mark, right? Now you have to explain it. Well, the way distillation works is it takes advantage of the difference in boiling point of ethanol and water. Ethanol boils at 78 degrees C and water at 100 degrees C. So what you do, you heat this solution to a temperature that's in between these two. Let's say about 85 degrees C is a reasonable heat, because at that temperature the water is still a liquid because it's below its boiling point, but the ethanol has vaporized. It's turned into a gas because it's above its boiling point. So the water remains here and the ethanol is a gas and goes up here. It's clever, right? Okay, so explaining that will get you the 2nd mark. And for the 3rd mark, what happens is the heat, this bit's being heated, but this is not. So this is cooler, there's a temperature gradient here. And it cools as it goes up here in vapor form, and it condenses. It condenses here, turns into a liquid, and drips down here and is collected as pure ethanol. Okay? So, to get the marks, the word heat gets you a mark. Saying that ethanol boils at a lower temperature than water, and therefore, if you heat it to 85, it vaporizes and the water doesn't, all that gets you a mark. And saying that it condenses as it falls back below its boiling point. It cools and its temperature drops below 78 and it condenses into a liquid, into liquid ethanol here. That gets you the 3rd mark. Good. And you've got to write a little bit on this. You can say things like it's collected as a pure liquid in a separate container over here. Yeah. All right, there you go. That is how distillation, and that's the essence of how vodka is made. That's probably confusing, the last thing I said, because I originally told you that vodka is 50-50 roughly, ethanol and water. So how do you make vodka? By changing it into pure ethanol. Well, they do this. This has got nothing to do with the question, okay? This is just a vodka lecture suddenly. Basically, they do this, but they throw in a few ingredients here. So they initially make, it's mostly ethanol, it's 99.9% or whatever ethanol, with a little bit of the flavour that also goes over with the ethanol from the flavour ingredients they throw in here. So you get essentially 99.9% ethanol with a few flavours in here, and then they add pure water to that. I think that's how they make it. That's got nothing to do with the question anyway. Yeah, so to make vodka, they start off with an ethanol, water, and ingredient solution. They turn it into ethanol and ingredients, and then they turn it back into ethanol, ingredients, and water. I think. I could be completely wrong there. Who cares?